This video is about graphing polynomial equations and investigating their end behavior, their degree, and their LC, which represents leading coefficient. That's just an easy way to abbreviate it. So in this first problem, I'm giving a graph, and from the graph, we know a lot of information. We can immediately see that both ends are going down. So we can write the end behavior of this graph as x approaches negative infinity, y approaches negative infinity. What this means, as x is getting smaller, y is also getting smaller. If we go to the other end of the domain, as x is getting bigger, approaching positive infinity, y is also approaching negative infinity. So this is what the end behavior of this graph is. Now, the next thing I can see here is that this particular function must have an even degree. It's got an even degree because both ends are going down. We can also see more about this function because we have a 0 here at 1, 2, 3, at negative 3, another 0 at positive 1, and then we have 1, 2, 3, 4, 5, 6. We have a double root here because I know it's a double root because it bounces. It bounces at a double root, or in that case, just an even root. So if we wanted to write out what this function could possibly be, it would be f of x equals x plus 3, x minus 1, and then x minus 6 to the second power. Both of these would be to the first power because it's passing. So it's passing through here, passing. But here it bounces, and because it bounces, that's how I know it has to be at least a double root. Next thing I know is because the end behavior is both going down, that means the leading coefficient would have to be negative. So now we're going in the other direction where we have the function and we're going to draw the graph. So I'm going to make myself some axes here, and this is nicely factored for us. If you get a polynomial that's not factored, you either have to try to factor it, and hopefully it will, or use the rational root theorem, which is better known as the P's and the Q's, in order to find the possible roots. So this one is factored. We're going to set each factor equal to 0, and we see that obviously, if we divide by negative 1 here, x squared still equals 0. So we have a double root. Boop, boop. That's a double root right there. A double root of 0. So that means that x equals 0, it is going to bounce. So we're going to have a bounce in the graph right there at 0. The next factor is x minus 3. That's x equals 3. 1, 2, 3. That is to the first power, so it's going to pass. It's going to pass at positive 3. And then our next root is also going to be a double root. X plus 2 quantity squared equals 0. Square root, x plus 2 equals 0, x equals negative 2. 1, 2. Again, at negative 2, it's going to bounce. It's going to bounce because this is a double root. Now, what is our degree here? The degree of this polynomial, if we were to expand it, would be 2 plus 1 plus 2. The degree is 5. So that's odd. The degree is 5. That is an odd root. So now that we know that we have zeros, a double root at 0, that's where it's going to bounce. A single root at 3, therefore it's going to pass. And also a double root at negative 2. The degree is odd. And one last thing, let's find our leading coefficient here. So we have a coefficient of 1, and then another 1, and then another 1. So our leading coefficient will be negative. So this odd degree function with a negative leading coefficient will be a decreasing function. That means it will be going down from the left to the right. So that means that we're going to start right here. Remember to bounce at -2. So we bounce at -2. Then we go up. We bounce again at 0. Now, who knows how high this may go up, but we do know that it goes up, and it does indeed bounce. And then we are going to pass at 3. So bounce and then pass. So our function would look something like that. Odd degree of 5, negative leading coefficient, zeros at 0, 3, and -2.